Great. I would love to talk to you today a little bit about the Dow perspective around innovation and how to separate or how to take invention into innovation. But let's set the stage first. We live in the chemical industry, and that's sort of kind of a pictorial of how that looks like. We take basically carbon-containing resources from Mother Earth and take them and convert them into a host of different types of materials, chemicals. At the center of this is a cracker, because it takes these saturated alkanes and decomposes them thermally into alkenes, which you then can react into all kinds of molecules or polymerize them into large polymers. These streams on the right side are roughly in the same ratio as the product sold. So if you really look at the chemical industry as a whole, it's like 7 products plus a host, a myriad of smaller products along the way. Dow obviously plays a lot in the ethylene envelope, but we also play a lot in the propylene envelope, but that is life in the chemical industry. So when you look at a snapshot of the gas prices over the last decade roughly, you saw that that's the red line. US gas prices were always in the average at the top until around 2008. And then something miraculous happened. Chris often mentioned it already. But when you look back at 2008, that was the sentiment in the industry. There's never going to be another dollar invested in the US. Some reports suggested to take some of the plants and then take them down and ship them overseas and build them back up and so on. And then something great happened. Shale gas was found. Nobody saw that one coming for some reason. And all of a sudden, ethane now tracks natural gas and not crude anymore, very recently. And so if you really look at it from an ethylene production, because ethylene is the key raw material, right? From an ethylene production cost in dollars per pound versus the global supply, you take the green curve, which is 2005, and you looked at United States was pretty much the most expensive way to make ethylene or place to make ethylene. Just 7 years later, it became one of the 2 cheapest places to make ethylene. So at this point, shale gas actually has spurred to an enormous amount of capital investment, hundreds of thousands of jobs, billions of economic output, and so on. And at this point, the US chemicals live long and prosper is the word. So by now, you're probably getting slightly concerned. What's this guy talking about? This is about innovation. This is not the raw material summit, and so on. So I'll put this into perspective, because from my perspective, it has to do everything with innovation for 2 reasons. Number one, the only way to decouple yourself, at least to some degree, from raw material costs is innovation. Adding so much additional value on top in the product that raw material fluctuations which always will happen, don't take you down. Because some of those one-trick pony companies that are in the commodity games, they sometimes have years where they have, offsites in Hawaii and whatever, what have you. The next year, they're flirting with bankruptcy. The way to differentiate yourself, the way to decouple yourself from that is innovation. But the other part that's very, very important is how to communicate innovation internally. How to make sure that a $1 billion plus in innovation sales may be offset in that quarter by a $2 billion increase in raw material prices. You have to innovate in that environment. You cannot ignore your environment. So it's very important to put all this into perspective when you do innovation, and also how you communicate internally. Because there's always, well, I can take those $1 billion in R&D and stick it into a new plant or something. Well, there's reasons why innovation is the only ticket to get out of this. So I hope I got your attention around that. And it was great to see that a lot of chemical companies are in here. So that's where we are, and that's what Dow really is changing and transforming into a different company at this stage. This is my Dow overview slide. I kept it entirely pictorial. I think it was mentioned already, we're almost a $60 billion company. We have about 50,000 employees, and so it's definitely a large chemical company, fully integrated. It's 117 years young. It started taking brine and converting it into bromine. Eventually, around the war times, we got more into the magnesium business. At that time, aluminum was not that cheap yet, so we were in the magnesium business. And then eventually in the 1960s or so went into the massive polymer type of business. We are still one of the top 3 owners and leasers of rail cars in the world. CSX, the biggest, but we are one of the second or third at this stage. So we make a lot of stuff, we move a lot of stuff. That's still part of our DNA. But we have focused on the downstream, on the value add. So if you look at some of those examples here on the upper left is a microchip. If you have a smartphone, and I know you all do, the chance is 90% plus that there's Dow, at least one, maybe more Dow materials in their interconnect side, on the display side, and so on. Structural adhesive, modern performance cars are getting glued together. The frame is getting glued together for light weighting, but also for performance and safety. We have OLEDs, water filtration units. So I could have picked any kind of examples here. A big, almost $7 billion agrochemical business. And of course, we never work on the active, but we do work on excipients for the pharmaceutical industry. So you can get the gist. We are moving downstream. We're moving into the value add quite extensively. So this is how we do R&D. We are spending a cool almost $1.8 billion in R&D spending every year. About 6,300 employees. You can see the patents granted are now, last year were about more than 560. And we get a bunch of awards over time. And so I wanted to just give you a little bit of a sense how we do this. We are looking for the most relevant IP that we can get. Ultimately, R&D is in the business of getting intellectual property that's meaningful for the company. And this is done by a German school, so it's got to be true. So we have the highest level of relevance in the chemical industry according to them. But we also have now really gotten a clear trend on the quantity of the patents at the same time. So what I would like to do now over the next 25 minutes or so is spend a little bit of time on what are some of the key ingredients and how we're focusing. There's a lot of detail around this in terms of our approach to innovation. And there's about 7 key ingredients from my perspective that make this work. And so I've wanted to start with where are we going to focus on. And when you're the last speaker, and first of all, I really thank you. Sometimes being the last speaker can be a very intimate experience. It's great to have so many folks still in there and seemingly awake, so that's terrific. But a lot of those things have been mentioned, and that's actually great because it's kind of a confirmation of that this kind of stuff actually works. But we took our businesses and kind of classified them into the performers and the not so performers. And you quickly see a few overarching themes. So if you look at the ones in green, green is typically good. That's the same on this chart. You see a couple of businesses that have high EBITDA, typically relatively high revenue too, and they're aligned with some of the mega trends, right? Agricultural science, well, very clearly, water and process, electronics, performance plastics is a little bit of a generic name, but it is honestly 90% packaging. And if you look at food supply and food waste and how to keep things fresh, packaging is an enormous growth area for us. Then you have businesses that are yellow and red here. Some of them are actually businesses that already were their true kind of product businesses, right? Epoxy can go into any market. So those businesses sometimes struggled a little bit in terms of finding an identity of where to drive value. So one thing that we have done now is look at this map after we looked at the businesses and then took a concentrated and prioritized approach to those businesses and doubled up on those. And so we're not prioritizing within the businesses anymore. We're now prioritizing across the company, if you want, right? So you can say performance plastic, we talk about it, especially in the emerging economies, there's a lot of growth coming up. Agricultural sciences, the population growth, the farmable land in the last 100 years stayed constant. pretty much. So it's all production out of the same type of land, right? That's gotta be big going forward. We talked already about that, it was mentioned several times, that exponential increase in electronic devices. We play in all those areas, very key. This is kind of the full set of markets that we're focusing on. More than half of them are aligned with what we call market-facing businesses already. But a few of them require several businesses to kind of work together and get their act together. And we're in the middle of really rolling this out and making very clear that here are a clear way to drive value in this market and what is all in there. And there's another point that's very, very important. Sometimes R&D gets equated with innovation. R&D is a part of the innovation process, sometimes more important, sometimes less important. It is a critical cog in the machine called innovation. But every function can make it happen or can screw it up in a way. So you have to have supply chain, the business leadership, the manufacturing, sales. Everybody has to own innovation, otherwise it's not going to work. And that's where this market focus comes here. These kind of businesses, we know what we're doing. We know the value chain. We know who makes the decisions, and that's where we're doubling up. Number two, you have to be organized the right way. We're a US company that's become global over the last 100 years. So it's not surprising that our the hub of the people is still in North America. But we now have very strong presence. If you take EMEA plus India, it's about 1,000 people. If you take the rest of Asia Pacific, about 1,000 people. Take North America, almost 4,000. And then even in Latin America, we have 500. So it's a large group. It's functionally aligned. If you're in a company like GE, you can have R&D aligned to the various businesses because the businesses don't have that much to do with each other, right? I was in GE Silicones at some point. We reported into the general manager of Silicones because the guys that worked on aircraft engines, we had almost no overlap. This is very different. There's materials flows across the businesses. So we take the full value out of it by being functionalized, by being functionally aligned across the company. Now, 80% of those resources are aligned with businesses, dotted line to their businesses. So they have the businesses on their various businesses on their mind. And then 20%, or a little less than 20%, are in corporate R&D. And they really serve two primary purposes, and I'm trying to oversimplify here, but leveraged capabilities that one business alone couldn't afford, and longer term stuff, very critical for the company. The type of research that we do is not surprisingly product research. We're trying to find new molecules and materials. Process research, sometimes underappreciated, can gain massive value for you. And of course, more and more application development. Some of it is short-term, some of it is actually not that short-term. So it really depends. But this is maybe the key slide on how do you invest that $1.7 billion. That's a lot of money to invest in R&D. The way we view this a little bit is like how you plan for retirement. You don't bank your thing on one thing, right? You have a little bit of, well, maybe not right now, but you have a couple of government bonds and you have stocks, low risk stock, high risk stock. Maybe when you're in your 30s or 40s, you have a little bit of some high risk stuff. Hey, if that makes it happen, if that becomes Intel, Google or something, then it can happen. So you play your odds in different ways, and that's how we do it in here too. The bulk, and it's highlighted here in blue, of course, is the basic is investment in our internal R&D capabilities, for sure, and that's critical. We will continue to do that. But then we also have, recently, over the last 3 years, have made massive investment into universities. It's a very critical part of our strategy for several reasons. Number one, it helps mitigate risk. You can try some stuff you couldn't really try at home. It would be scrutinized, so you can try some higher risk stuff. Number two, it's your recruiting pipeline. We only go to the top universities. We have good relationships. We have sort of preferred status. It's like being platinum on Delta, so that kind of thing. And third, you can actually kind of direct the work they're doing. We came to a point, we're a big chemical company. We came to the chemical engineering departments of this world, especially in the US, And a lot of those, because of federal funding, had started in the bio area, right? So we need engineers that run a $3 billion plant, but they're working on fermenters and stuff like this. So there was actually a mismatch with what was coming out of the grad schools and what we can use. So that helped us with that part too. Collaboration and external funding, another big area. Most of those collaborations are kind of low, private, but some of them are quite public, like the Ford Dow. It came up in the material session yesterday, Ford Dow. I was in the middle of that one. And those we drive for total integration here. If you go to a Ford Dow meeting right now, which actually also includes a tier 1 supplier and a few other folks, you couldn't pick out who's from Dow, who's from Ford, unless you check their badges. That's how integrated that happens. Because our skill sets are complementary. Our knowledge is complementary. It works that way. So we always try to make sure. It's very hard for us as a material supplier to partner with another material supplier because there's always this, oh my God, they could find something out, right? So it's very critical how to pick your partner and how to be successful in this one. And then we have also some folks here, we have venture capital. We work very closely at Greer's here, very closely with our venture capital group that looks for new technologies, tech scouting, and so on, and see how we integrate that and helps us prioritize the longer term efforts. So it's really that kind of portfolio. And where we invest depends a little bit on how much risk we're willing to take in a certain period of time. So that can fluctuate a little bit, but that's really the balance of investment across R&D at this point. The next one, I was a question this morning about metrics, which I thought was quite interesting. You're typically going to get what you measure. That's just a fact. And you have to be very careful. In the classic metrics that you see everywhere is, R&D is a percent of sales. What are your new product sales, products introduced in the last 3, 5, whatever years you want to pick. The number of patents. A lot of them are quantitative metrics. So they're easy to measure, which you like. But they're sometimes very hard to it's very hard to find value out of those metrics, right? So we kind of retooled our metrics. We're still going to measure those because they're kind of given. But we try to get some new metrics in there that gives us a better sense around productivity and value. So new product sales divided by the R&D spend. So now you get a sense of how much sales are we come and what kind of percentage is that compared to that R&D spending. Margin on new products. If you introduce a new product, it better be a higher margin, a better value than the one it replaces, especially if you're sort of in the same space, right? So you want to upgrade the company in terms of value. So if we check margins all the time and look for what are the issues, why is it not happening? Patent advantage sales, which are the sales where we make high margins, where we then can compare about IP protection, what we have here. This is on purpose a busy slide. It just shows you that we take measuring relatively serious. A lot of this is more or less automated. But there's a discovery phase which you don't want to measure. That's where actually a lot of the creativity comes in the first 3 to 5, 3 to 6 years and so on. Then comes the sort of, we call the development type of phase. We run that by what we call a playbook. It's an annual process, but honestly, it's kind of somewhat living throughout the year. And I'll give you more information around that one. Then comes where the real tracking information comes in. After the product is introduced, we're going to take a look at it in excruciating detail for the next 5 years. That includes geography, business, margin versus the same similar type of product and that kind of stuff, okay? But the problem is, especially in material space, if you introduce a new product, there's an S-curve, and sometimes even in 5 years you don't hit the uptake really right. So you got to keep on taking a look at it, and so we even on the ramp up we can continue to track it. Product development process was discussed already before. That's our version of it. It's interesting how different companies have quite similar processes. At the same time, there's always some uniqueness to it. This is very important. A process is critical to keep you on track, to make you ask the right questions But if you try to let the process take over, you're screwed. There's no way. The process is a tool. The process can help you, but it's not a life of its own. So we typically try to, upfront, we are very generous. Concept shaping analysis, we try a lot of stuff. There's almost no bad idea. Well, there are some, but there's almost no bad ideas. Then when it goes into the validation part, that's when it's getting interesting. All of a sudden, we pull all the other functions in there. There's a big review with all the functions, and then, because now we're starting to invest. Once it goes from like a 200, 300K project to a $5 million project, that's real money. And you can't do it for 3 months, right? You're kind of committed. So if you want to do it, let's do it right, 5 million for 5 years. You can get the picture. So that's where we're going to have a lot of the big discussions around here. And that's where a lot of the other functions are getting pulled in. And honestly, they all have to own it. Very critical. They all have to co-own it. And the business leader is typically, or general manager is typically the one that ultimately has the final say. And then we move it into scale-up development and eventually into implementation. So this is a slide from this innovation growth playbook. This is exactly the formatting we used. Obviously, our products are proprietary, so we made up a fake project for you. And the idea here is, if you could grow in our ag business a totally cubic melon that would be very good for packaging, and so you could, in one truckload you can bring a lot more volume of melons around. So that's sort of the hypothetical example here. This is how we run this every year, exactly that format. So we have like a market opportunity statement, a somewhat more or less detailed technical project description, and then comes maybe the key part. And wherever we failed, most often we failed in the value proposition. Because a lot of people confuse product features with the value for the customer. And there's several examples where it just didn't work out. I was in the automotive space before. We worked on engine oils with a very, very long alkaline glycol type of materials with a very long lifetime. Well, it depends who thinks that you and I buying this car, not having to have an oil change for 50,000 miles is awesome, right? The dealer doesn't think so, because that's a main revenue stream. So you have to understand where in the value and who is the decision maker in the value chain, and does this project make sense for the person, for the company, for the entity that actually decides in the value chain. That's where we made probably our most critical mistakes. Competitive landscape milestones, the typical, how is the IP position going to change over time, and of course the financials. Next part that's very important, play to your strength. I worked in companies as large as 350,000 employees, and before I came to Dow, I worked for a company with 22 employees. I've seen it all. 5,000 at Momentive, 50,000 at Dow, so you get the picture. It's probably not news to anybody that 22 people company is quick. We can make decisions at the water cooler within 2 minutes, and there's no 15 people sign off. Speed is your asset. Play for speed. If you're 50,000 people, if you have a $1.7 billion R&D budget, play for stuff that the little guys, the single companies can't do. And that's leverage capability. At some point, there comes a point, if you don't play for that, a diversified company that has different businesses, at some point it begs the question, why aren't they separate businesses? Unless you have a card to play, and that's your competitive advantage. For us, one of those, there's several to pick, but one of them is high throughput capability. High throughput capability was obviously started in the pharmaceutical industry. The problem why it hasn't fully delivered in that area is you sped up the front end, but there's still a 7-year plus clinical trial period, which you can't really speed up in any way. So that's one of the issues. We don't have that. So we went all full bore. If we made an estimate over the last 14 years, people, equipment, materials, probably put about $1 billion into this, close to it, into this capability. It is massive. I'll give you 2 examples around that. I'm a scientist still, sort of, and so I'll give you an example around how we leverage this. And you have to do it either full force or not at all, I think. From the experimentation up front, we can run now, our record is a piece of equipment that can run, that we made for agricultural science, that can run, hypothetically, up to 32,000 experiments per day. That's a lot of experiments. You can do a lot of stuff there. But the problem is you cannot create a bottleneck somewhere else, right? So then you get stuck with the analytical and so on. Now, we have everything. We can run GPCs, gel permeation chromatography, 100 per hour or 60 per hour, depending on. So there's no bottleneck. It goes all the way through. And that's our competitive advantage. A small company cannot afford that. A single trick company, one business in one area cannot afford that. We can. So we got to play that card, right? You can see all the areas that we're covering here. We cover this across. And I wanted to give you just an example. Don't worry about this. Well, you could worry. It's a very exciting chemistry. One thing that happens in the polyethylene space, there is a correlation, it's that curve here, between the polymer density and its thermal resistance, thermal properties, okay? And it's a perfect curve. And we couldn't get off that curve. But those lower density materials, these elastomers, actually have very cool properties that the customer wants, but it's not. You're running into problems already at 60 degrees. Well, you can't use that anywhere. So these elastomers are made by actually copolymerizing some octene into the chain. So when you take ethylene and polymerize it, make that one chain, well, if you can take octene in there, it creates some fluffiness if you want, right? So we use that capability that I just talked about in some detail and found 2 different catalysts. One of them that only does ethylene. This catalyst doesn't do anything with octene. Octene comes around, I'm not going to polymerize you. But ethylene, full force. The other catalyst doesn't care. Anything, bring it on. I'll polymerize you. So then we created a system where the polymer chain actually moves between these 2 catalysts back and forth. So now you get a block of only ethylene, catalyst 1, then a block of where octene is just as much in there, whatever you want to add, and then so on, and it goes back and forth. Those have unique properties. They are up there. They are very low density, very cool, elastomeric, and now have all of a sudden much higher thermal properties. But here comes the killer. Totally different scenario. Don't think about ethylene anymore. Now you think about OLEDs, organic light emitting diodes. It's a I'm not going to go through this in detail. There's a multilayer structure. Critical, obviously, is the emitting layer. Emitting layer is based on an iridium compound. Iridium is one of the rarest elements on the planet. It's mined at around 3 metric tons per year. If you switch over OLEDs into flat screen TVs or so, you need about 50 metric tons. Well, Mother Earth doesn't have 50 unless we mine it on some planets. Some people have these type of ideas. So your better option is actually to move to a different metal in the middle. Well, we use the same capability, the same researchers, sometimes similar ligand systems. We have hundreds of thousands now because of this high throughput capability. And we can now check all kinds of new molecules, and we're now getting emitter that are better based on a metal that's ubiquitous in Earth. But the point I'm trying to make is you have that one capability that neither one of those 2 businesses separately could afford, and now draw it in and and get unique results. That's the power of a big company playing its card, right? And here's even our final photoluminescence screening tests are done in a high throughput manner. Now, it starts and it stops with people, and that's clearly the most important part around this, right? So we talked a lot about around people development and getting talents from universities, and we heard a lot about culture. Culture is probably the number one. I mean, even 2 days ago on the radio, I heard about Kobe Bryant lamenting about the culture, the LA Lakers. It's everywhere, right? I mean, if you don't get the culture right, you have a problem. So that is one of the key areas, and then we're building it on top. So this is our effort now to really concentrated effort on getting the maximum out of our university relationships. As I mentioned, it's about 25 million per year. We're funding 11 universities, those 11 here. We have about 10 other universities that we also use heavily for recruiting, but those didn't sign our specific intellectual property agreement, and the master research agreement could never been done, so we focus on those. And we're very happy with those, and it's a wonderful relationship, and it allows us to have those projects big enough to actually do something sizable, right? The other part that's important, and that's kind of the same thing with open innovation. We don't do much open innovation at all, honestly. But it's a similar kind of thing. You can throw some money over to university and says, here's your project charter, see you in 2 years. And you get all kinds of stuff, but it will have nothing to do with what you originally wanted, right? Because they wander off and there's a cool result and then they go that way and then that way. They publish all places. Great. It's not useful for us. So you have to internally invest a large amount. It's actually somewhere between 5 and 10 million, depending on the year and depending on the projects we're looking at, to really closely interact with these university programs, to keep it on track, to see what makes sense, what doesn't make sense, and where do you want to go from here. So those are, if you look at this, I call it the Dow Innovation Cocktail. There's about 7 pieces that are very, very important. The last one is by far the most important one, and it captures several items. But we're trying to focus, as I mentioned, on attractive markets, but also at markets where we have, where we know what we're doing, where we have the total value chain locked up, where we have our supply chain locked up, where we know how to serve it, where we have the right relationships, the right insider information, and so on, and which are aligned to the megatrends, largely transportation, agriculture. We talked about it. Global reach and footprint. We have centers of excellence, and a lot of it because we started in the US, they are in the US, but we have them everywhere. And we have a good balance between the corporate R&D, the business-driven R&D, the technical service and development, and the kind of the global reach. So we are the center, a lot of the centers of excellence, as I mentioned, still in the US, but driving into the various regions. A diverse investment portfolio. We don't put all the eggs into one basket. Very, very critical. There's government funding, there's university funding, there's all different pieces that all have to come together. Meaningful metrics. These we have to double check all the time, and we change them. We're not so afraid. The key ones, so it's actually a balance that we have to strike. So some of the key ones we do not change. And the reason is because you cannot get a good track record and compare with the past. But we have to add and see if they're right. We tinker with them, I would say. A structured yet flexible process. The flexibility is key. We're trying to make sure that there's time, that the process should help you. The process should not limit you. The process just should help you ask the right question at the right time. That's really what it is. Play to our strengths, leverage capabilities, massive analytical capability, massive high throughput capability, trying to play that card very hard, and then the people and the people and the people. That's where it all starts, that's where it all ends. The culture that you have to drive, and that has gone back and forth a little too, but it's got to be inclusive, it's got to be team-oriented, but it's got to be like, do it. Just this Nike commercial, just do it. Very critical. Ask for forgiveness later. The only times where the ask for forgiveness is not working. So safety and ethics is where we don't take any compromises. The rest, just go do it, make it happen, and that kind of culture gets you far. So I hope this was helping you a little bit. That's our way. There's a lot of detail. Those are the processes. Those are the pages. It just was sanitized, but that's how we drive innovation. And for me, it's been a terrific 2 days. I got to meet a lot of people, and it's always great when we talk to to small companies, because I lived in one before, and it's wonderful to see. Honestly, I think a lot of the world's problems will be solved by large and small companies working together. At least that was my perspective, coming from a 22 people to a 50 plus thousand people company. And with that, this is your final presentation for the day, I think. Thank you.